Hello and welcome. I'm Pierre Lanary. I'm assistant professor at the University of Bern in Switzerland. It's a great pleasure to see so many of you connected today, and I want to take this opportunity to talk about XMapTools. So XMapTools is a MATLAB-based software solution for processing chemical maps. It comes along with a graphical user interface providing a guided environment for data processing and data visualization. The processing engine is at the core of XMapTools, and it includes a user-friendly function for classification, but also for calibration and data normalization. Software development is an important part of my research and has become today also critical for the scientific community in a broader sense. I have dedicated some of my time in developing XMapTools from version 1 to version 3, with in between more than 25 updates released in the past decade. And this corresponds to about 3 versions released each year. We have also dedicated, with collaborators from all over the world, a lot of efforts for training users. We organized a series of training sessions, first in Europe with an important event in 2015 in Potsdam, organized by Amaury Pourteau. Later on, in 2018, we had the first overseas workshop in America, organized by Mayra Tedeschi in Belo Horizonte in Brazil. And the number of in-person events has increased over the years. And as a consequence, the number of users has grown constantly, reaching a total of almost 2,000 registered users today. And this is fantastic, and I'm very grateful to all of my collaborators who have contributed to reach this achievement. Although this success, XMapTools remains a free software for academic research. It is widely compatible with a large set of instruments of data. For example, electron beam instruments, electron probe microanalysis, scanning electron microscopy or micro X-ray fluorescence. In 2017, together with Tom Raimondo from University of South Australia, we implemented several tools to handle laser ICP-MS data. So XMapTools contains essential features for quantitative petrology, and one of the key advantages is that it was developed by a petrologist. And this makes it very different from any existing commercial software. Users are the main reason of XMapTools' success, and I would like to take this opportunity to thank you all. XMapTools has been built for users, and many tools were inspired by you. So thank you for this essential contribution. But the growing popularity of the software is also a huge challenge for us, and it has become more and more difficult to keep on developing the program and implementing all ideas that we had in mind. The architecture of the program was designed more than a decade ago, making further growth no longer sustainable. And this is why today we are presenting to you the biggest step forward in XMapTools history, that is XMapTools 4. And I hope that we will convince you in this presentation that this version is simpler, faster, and much better than what we have done before. So XMapTools 4 marks a transition after 10 years of development, and it will update the core experience of the program. There are so many new functionalities, and I'm very excited to show you today part of what we have prepared. So let's start with the most important aspect of any image processing software, that is the interface. So XMapTools 4 will come with a fully redesigned graphical user interface. It will include modern and interactive visualization tools. And as a consequence, more data can be integrated together and remain easily accessible. This is the new version of the redesigned interface. Although I'm sure it seems to some of you very different, I'm convinced that you will feel comfortable using it in no time. Plotted data remains at the center of the graphical user interface. Tools for adjusting display are easily accessible just next to the map. We implemented 2-3 menus for efficiently accessing the data, and it has never been so easy to display a map at any stage of the data processing. XMapTools includes many functionalities, and the buttons to access those are now located in an upper panel. The structure of the program has been updated to focus not on the kind of data that you process, but on the main steps of the data reduction procedure. Finally, we also updated the live display with a live histogram, allowing users to interact more closely with the plotted data. We added data, information, and plots, for example, for sampling functions that are located all in a panel on the right side. So this is what we have prepared for XMapTools 4, coming with a brand new design, 3 menus for data organization, and we hope that this will improve accessibility and compatibility. But we want now to show you how we think the new interface will improve the user experience. And for that, I'm inviting Josh Lawton to join us here. So Josh is a PhD student at the Western University in Canada. He is part of the development team of XMapTools 4. It's a real pleasure to have you here, Josh, with us today. So please tell us more about the new interface of XMapTools 4. Josh, the stage is yours.
Thanks, Pierre, and hi, everybody. So here I have XMapTools 4 open, and I have a project file open of a garnet biotite metapelite. And currently you can see the silicon intensity map. And if I want to switch between the different maps that I have, we can use the new tree menu on the left here. So I have a folder of all my intensity maps, and I can switch between the different elements here. And then we also have a folder of the different quantitative weight percent maps. So if I want to look at the garnet weight percent maps of calcium or potassium or magnesium, I can select those all here. And then we also have the merge section here. So this shows all of my weight percent maps of all of the phases merged together. And you can see on the right the new live histogram feature. So you can see the range of values we have. And now if we want to adjust that range of values, we can use the auto contrast button. So if I select that, you can see the range of values is minimizing, and then I can select it again to restrict it even further. Now, a really cool feature you can do is manually adjust these boundaries. So if I just click and drag these red bars here, I can highlight these middle peaks here if I wish, and that will change accordingly on the map that is being viewed. Next, I'm going to show you how to do the sampling. So for the sampling, we just click on the right here, the sampling tab, and then I can choose the kind of sampling feature I want to do. In this case, I'm going to use a circle. And let's say if I want to sample this garnet grain right here, I just select my region of interest that you can see highlighted there. And then on my histogram, you can see the value. So in this case, it's about 21 weight percent aluminum. And another cool thing you can do is just click and drag this region of interest, and then you'll see my sampling amount is being automatically adjusted, and I can also adjust the boundaries however I wish, and that'll automatically be calculated on the histogram. Another new feature is the scale bar. You can automatically add a scale bar on your maps, which you couldn't do before. So for that, I just on the top here, select the resolution of my pixel size. So let's say it's 20 microns for each pixel. Just hit the checkbox. And on the bottom left here, you'll see my scale bar pop up. So in this case, it's 4,000 microns in the scale bar. And then lastly, what I'm going to show you for the basic interface features is if I go over to the Calibrate tab here, and if I want to select I can select a region of interest to extract a local bulk composition. because that's one of the coolest things we could do with XMapTools. So if I just add a region of interest, let's say I want to do basically my whole map here, I select that. And then on the right here, you'll see my bulk composition of that region of interest has been automatically calculated. And it also gives me a pie chart here of the different weight percents. And then just like the sampling feature, we can adjust the region of interest here. So if I want to get rid of this sillimanite bearing zone, I can just adjust the boundaries by clicking and dragging. And you'll see on the right, it is automatically adjusting the local bulk composition that's being calculated. And I can also click and move this field as well. So that's it for the basics of the XMapTools 4 interface. And now I'm going to send it back to you, Pierre.
Thank you, Josh. Thank you very much. That was a very nice demo, and I'm sure you convinced everyone watching here about the benefits of the new interface. One of the key advantages of this more flexible interface is that XMapTools can now handle more data than before. In addition to the traditional capabilities for EPMA data, XMapTools is now fully compatible with SEM data. Here is an example on the top right of a compositional map that was calibrated with the Zeiss software. And with this data, you will have access to all XMapTools functionalities, including, for example, the classification tools. XMapTools is also now fully compatible with laser ICP-MS data and with microcomputed tomography data. There are several new functionalities that were implemented, bringing the overall experience to a new level. So next, let's talk about classification. Classification is a critical step during which pixels are classified into groups corresponding, for example, to different minerals. To achieve that, we need to select a classification algorithm that will generate a classifier based on a set of training data. And the idea is to train the classifier first with a pre-selected set of data, and then to apply it for the classification of the entire data set. So classification has evolved significantly in XMapTools 4 with the introduction of training sets. A training set simply contains a set of compositional data for each mineral or object to be classified. And they are created and manipulated using interactive selection of region of interest directly on the maps. And these training sets are then combined with a machine learning algorithm for classification. Here is an example of a chemical map for iron expressed in intensity. And you can see that the different minerals seem to be easy to identify on this image. But the problem is that we have one mineral, epidot, recording a quite strong compositional zoning in iron. And this data set is usually a challenge for any classification algorithms. For example, those that are implemented in XMapTools 3. In XMapTools 4, the training set can contain as many compositions as you want, so it is straightforward to pick, for example, with the interactive tool, several regions of interest containing the training data. Here, I have collected 5,500 compositions that were then used for training the classification algorithm to recognize epidot. And XMapTools 4 comes with 6 new machine learning algorithms dedicated for classification. We have, for example, implemented the random forest algorithm that represents, in our opinion, the most efficient way to classify a complex data set, but there is more. Each algorithm comes with a set of optimized hyperparameters, an uncertainty estimation, as well as tools for evaluating, for example, the importance of each predictor. These developments make the classification in XMapTools 4 much easier and much more efficient than what was available before. And to show you this, I'm inviting now on the stage Mayra Tedeschi. So Mayra is assistant professor at the Federal University of Minas Gerais in Brazil, and she's also part of the development team. It's a real pleasure to have you here, Mayra, live from Brazil. So please show us what are the capabilities of the classification environment in XMapTools 4. The stage is yours.
Thank you, Pierre. Hello, everyone. It's great to be here today to show you how do we do the classification on XMapTools 4. So here I have the aluminum intensity map for garnet clinopyroxene amphibolite. And the first step, we come here on the tab classify. And as Pierre said, we need to create a new training set. Here I have already created one, including all the minerals that I have found on this sample, but I will create a new one to show you how do we do that. So first we press add a training set for creating a new phase definition, and this button has multiple functions. So now we use it to add a new phase, and you can see here that we can rename the phase, for instance, garnet. And by pressing again, we can select a region of interest, as Pierre has shown in the previous image. So we press here, in this case, rectangle is selected, and we can add the region of interest here. The next step is that we need to select the algorithm that we want to use. And in this case, we are going to use random forest that has shown very good results in our test. And we use then this button, add maps for classification, to add the intensity maps that we are going to use to classify our map. And for any reason you want to exclude a map and don't want to use it only for the classification, you need to select the map here in the primary menu and press the button to take, in this case, potassium out. So then it will not be used here. And the next step is then we need to select the training set and press classify. By pressing this button, we will create a mask file that I have here, the random forest. It's very quick. In this example, it took 1 minute. And then we have the mineral's name here and its distribution on the map. And a nice feature is that now we can use the control button to select, for instance, more than one phase, like garnet and amphibole. And we can show its composition on both phase or two or more phase at the same time, like to compare how their composition are changing. So this is how we perform the classification for EPMA maps. And so back to you, Pierre. Thank you.
Thank you, Mayra, for this brilliant demonstration. It is crystal clear that the new classification tools are a major feature of the new XMapTools. And I have to say that during the testing stage, we easily managed to classify all examples that were involved. And it makes me very confident that everyone will like the classification in the new version. So next, let's talk about data calibration. If you deal with mapping data, there are two important steps for obtaining fully quantitative chemical maps. The first step consists of transforming the data collected as time series by rastering, for example, into intensity maps. And the second step involves the standardization of the raw data, our intensity map, into compositional data. Although the first step is performed automatically by most of the electron beam instruments, it is not the case for laser ICP-MS analysis. So I collaborated with Francesca Piccoli and Thorsten Markmann here at the University of Bern, and I can announce that XMapTools 4 will allow users to generate intensity maps from time series obtained by laser ICP-MS. We are also introducing a special assistant for advanced data calibration applicable to very complex situations. We also implemented a module for data conversion, permitting a full integration of laser ICP-MS maps with, for example, access to structural formula functions. Here is an example of the converter for laser ICP-MS data, where time series data are being imported and corrected for background. Primary and secondary reference materials can be selected, the drift approximated using various functions, and results and quality control tools are directly available in the module. So you can check the quality of your standardization. Finally, intensity maps can be generated together with standard data. So importing raw laser ICP-MS data in XMapTools 4 will be simple and quick, but also you will keep a full control on the main steps, and that's very important for us. Here is an example of what data this converter module produces: a series of intensity maps for your sample, one for each element, along with intensity maps for the primary standard, accounting for instrument drift, and combined with a compositional map of the primary standard, shown here on the right, and a value for internal calibration, it becomes possible to calibrate each pixel of the intensity map into a composition. This step is achieved using the calibration assistant for laser ICP-MS data available in XMapTools 4. Each mineral can be calibrated independently using the reference composition of one element. We developed this module having in mind the most complex situations, and therefore it is now possible to calibrate all minerals separately and to handle zoned minerals, for which a fixed composition cannot be assumed. So this is a nice development for the laser ICP-MS community, and I'm very excited to see the amazing applications that will come out. We also worked to improve the standardization procedure for EPMA data. And we are convinced that the internal standardization as it is used in XMapTools 3 is the most flexible solution for map calibration. But it's not easier for users because it requires a lot of work. So we have been working on developing and improving the calibration tool. And XMapTools 4 will have an artificial intelligence-based module for multi-phase internal calibration. A first version is already available, and we are expecting significant progress in the coming years once the algorithm is trained to face the most challenging situations. So we want now to show you live what the new calibration module is capable of. And for that, I'm calling Mayra again. So please, Mayra, show us more about the new calibration module available in XMapTools 4. The stage is yours.
Thank you, Pierre. So after doing the classification, we are going to do now the calibration for EPMA maps. The first stage is that we need to import the standards that are the spot analysis, and by pressing this button, they will be displayed on the main screen. And here on the right side, the standards window pops up, and we have here the plots to check the quality of the position. And here, if we need to do any correction, we can use these plots. We can also do on this new version, what we can also do on this new version is to add a new standard. And to do that, we press add. We select, for instance, on this silicium map, we click here that I know it's quartz. And by doing that, we come here and we see that there is a new spot here that you can rename as quartz. And you need to press the composition here of this new standard and press enter. After doing that, we have already the standards data, and we need to select then the mask file, and the button calibrate will become available. When we press this button, a new window will pop up, a window in which we can check the calibration curves for each mineral. And here we have, for instance, for garnet, here are the all calibration curves for garnet, and we can also check how are the calibration curves for each element, for instance, here for the calcium. And here we have the results for the quantitative results for calcium, while here we have the total weight % for garnet. And we can do this, we can perform manual adjustments if necessary, and we just press apply standardization. It's much simpler and much faster. what the program does is that it performs first a general fit, and then it improves the calibration for each mineral. By doing that, we have the quantified maps here, the fully quantified maps here that we can check here, for instance, and we also have the merged maps. And as Josh has shown you, by selecting, first we need to, if we want to extract a local book composition now with the quantified maps, we need first to create a density maps. So the first step is that we select a mask file, we press density, generate density map from mask file, and here it will be filled with the density data from our database. We just press OK. And we select a merged map, and the button to add the region of interest will become available. So we click here, and as Josh has shown, it's interactive, and we can see the change in the composition by changing the location of our region of interest, and we can also select another different region of interest by creating a polygon. So that's how we obtain fully quantitative maps from our semi-quantitative maps, and that's it. Thank you, Pierre. Back to you.
Thank you very much, Mayra. And I'm convinced that all users of XMapTools 3 are now convinced that the new version will bring significant improvements compared to what we have been using now for years. But there is more than that, and we have to move on to the next step and talk about external functions. So external functions have always been one of the key features of XMapTools. And in the next version, we have developed an advanced engine for external functions that allowed us to improve the functions themselves, to make them faster, for example. And we also implemented new calculation types. So in XMapTools 4, it will be possible to calculate a temperature map using trace element thermobarometry, or age maps using age dating techniques. And finally, we also implemented the PT toolbox by Josh Lawton. And of course, Josh is obviously the best one here to present you what is new concerning external functions. So please, Josh, go ahead. The stage is yours.
Thanks again, Pierre. So here again, I have the same garnet biotite metapelite project file open that I had earlier. And this time I'm showing just the calcium weight percent maps of the garnet. So you can see the calcium zoning in these garnets here. Now here I'm in the functions tab, and I can apply different functions to our map. One thing I can do is extract the structural formula of the different minerals that have my maps. So in this case, if I want to get the structural formulas of these garnets, all I have to do on the left here is first select the phase that I'm concerned with. So we have a bunch of different phases you can select from here. In this case, it's garnet. And then I can also choose to either include the ferric iron content or not. In this case, I'm going to exclude it. So all I have to do is hit apply, and it's all done. So now I just go over on the left to my tree menu and go to the results tab. And you can see now we have this garnet section here, and we have all of these different maps that have been calculated. So we have, see, the magnesium cations, we have the iron cations, calcium cations. So for calcium, you can see it's changing from about 0.1 cations to 0.16. And then we also have different variables, activity variables. So you can see we have here like the grossular or the pyrope concentrations here for the garnets. And you can do that for any of the minerals we have in the list here. Other functions we can apply are thermobarometry functions. So in this case, we have two different modes. We have a map mode and we have a multi-equilibrium mode. First, to go over the map mode, we can apply different thermometers to the entire map of a specific mineral. And we have a bunch of different minerals here. In this case, we know we have biotite in this sample. So we're going to do biotite. And first, I'm going to switch over to a biotite map. So here I'm going to switch over to the biotite titanium map, because we are going to apply the titanium and biotite Henry 2005 thermometer that's been coded into XMapTools 4. So in this case, all we do is bring up our biotite map, we hit apply, and then just like before, we go back over to our results tab, and we can see we now have a section of biotite here, and we have a few maps that have been calculated. First, we have the temperature based on the 2005 thermometer. So if I hit the auto contrast button, we can see in our histogram here, our values of temperature range from about 687 to 770 degrees Celsius, but most of them are concentrated around 759 degrees Celsius. The other and first, we also have other maps here that have been calculated. So we have the titanium cations per formula unit, and we also have the magnesium over iron concentration here, because those are both variables that are used in this specific thermometer. The other type of thermobarometry we can form is multi-equilibrium thermometry. So this is kind of your traditional garnet or two-phase pair thermobarometers. So here we know we have garnet and biotite. So first I'm going to switch over to a merged map showing my iron weight percent content of across the entire map. And we can see our garnets in orange here and our biotite in the light blue. Now, if we select the mineral that we want to do, we're going to select garnet, and then we can see all of the different calibrations of all the different garnet pairs we can do. So we can do garnet biotite, and then we can also do stuff like garnet chlorite, clinobroxine, cordierite, hornblende, ilmenite, and others to come in future updates as well. In this case, we're going to choose biotite, and then I'm going to zoom in on some of the garnets and biotites here. And we have to select regions of interest that are going to be used for the thermobarometry calculations. So we're going to hit add regions of interest. First, it's going to ask us our pressure, so I'm just going to leave that as the default pressure. And then I'm going to first select my region of interest for garnet. In this case, let's choose this area of the garnet here. And then next, I do biotite. So I'm going to do this little area right here. And then on the right, it's going to automatically calculate our temperature based on these regions of interest for those minerals. And the new feature with XMapTools 4 compared to XMapTools 3 is you no longer have to calculate the different thermometers separately. Now it's going to calculate all of the thermometers that we've coded in together at once. So you can see here, these are the different temperature values for all of these 10 plus different thermometers that we've calculated in, ranging from publications from 1976 all the way to 1992. So you can see there are different temperatures there, the standard deviations. And then if we scroll down here, we could also see the garnet composition used for that for the thermometry function and the biotite compositions. And then if we want to adjust our regions of interest, just like before, we can easily do that. So I can take the garnet one here, make a smaller area, or I can move it around. And I can also do the same for biotite. And then if we go up to the temperatures here, you'll see everything has been changed automatically. So these temperatures and the mineral compositions are automatically calculated based on the regions of interest that we've selected. So these are just some of the functions you can perform with the new XMapTools 4. There's many more and many more that will probably be added in the future. So now I will send it back to you, Pierre.
Great. Thank you, Josh, for this new demo. And also, I'd like to thank you for putting together such a nice set of functions. And I have to admit that I'm quite a big fan of your PT toolbox, and I'm really glad that you offered to implement all those into XMapTools 4. And I'm sure that many others will be as well. So before to conclude this presentation, I want to quickly talk about compatibility, as I'm very sure that many of you may have tons of questions concerning the transition from XMapTools 3 to XMapTools 4. First, it will be straightforward to open in XMapTools 4 any existing project that was generated with XMapTools 3. We kept saving all data within a single project file, and those data remain accessible outside XMapTools if needed. And finally, we have worked to improve compatibility, especially for data coming from various sources. And for that, we improved the converter that can now natively read data from geol and chemical microprobes. We have also joined a collaboration with Rich Taylor from Zeiss to ensure that quantitative maps generated with their software can be readily imported into XMapTools 4. And I've showed before that laser ICP-MS data can also be imported and processed in XMapTools 4 without the need of any other program. So as compatibility is a key aspect, we are looking forward to adding more compatible formats in the future. So if you have a format of data that you can't open in XMapTools, contact us and we will make an update for that. So for those of you who are afraid about upgrading to the new version, I would like to tell as well that we have and we will put even more efforts to help you to achieve this transition smoothly. So XMapTools 4 will come with an integrated user guide directly accessible in the program at any step of the processing. We are working on a resources website that will contain articles describing the main steps of the data reduction procedure. And finally, we will try in the future to produce tutorial videos and virtual classes to train the user to use the new version. Now let's talk about a very important aspect, that is how and when will the new version become available. So concerning the how, I have a great announcement to make that XMapTools 4 will be completely MATLAB free and will come as a standalone application for macOS and Windows. The program will also be still available within the MATLAB environment as an app, allowing you to do even more with your data than what we can offer. And finally, XMapTools 4 will be fully open source, and the source code will be available for everyone on GitHub, not behind any registration wall. We are convinced that open source model is the future of scientific software, and we are going 100% in that direction. Concerning the release date, XMapTools 4 will be available for all of you starting next week on December 6th with an open beta program. We are very excited and we hope that you will be mainly to sign up and to try the new version. The final version of XMapTools 4, including all features, is expected to be released during the spring next year. So we presented you XMapTools 4 that will be released next week as a beta version. It will be available as standalone applications for macOS and Windows, and it will be fully open source. It comes with a redesigned graphical user interface and modern interaction tools, as well as machine learning algorithms. XMapTools 4 can read more data types than the previous versions for EPMA and SCM data, but also for laser ICP-MS and microtomography data. We will also provide some training material to help you to get started with the new version. And in terms of performance, because this is really important, I'm quite confident to announce that XMapTools 4 reaches up to 400 faster performance than XMapTools 3. The time required for processing a single dataset has been reduced drastically, and we have tested that on many people. So from an average of about 2 hours with XMapTools 3 for an experienced user, it's now less than 30 minutes with the new version. It was a real pleasure to show you some of the new features of XMapTools 4, and we want to thank you for your interest and for joining us today. You can ask your questions in the chat on YouTube, and we will join you in a minute to answer them all. I would like also to thank Maira, Josh for their demos, and Thorsten for his assistance with streaming. Thank you all for watching, and see you hopefully in person very soon.